Hi, in this video I will show you guys how to solve one of the questions from the homework. Okay, so this is exercise 11H, question number 3 here, right? So let me switch to my board. Okay, so here it is. I've cropped the picture here. Go ahead, pause the video and make sure you understand what they want us to do. Okay, so for part A, they want us to draw a diagram to model the situation. Alright, so let's do this. This is A. So the boat, let's say the boat starts from here, and then it's gonna go to the west direction, right? And we have a lighthouse. The lighthouse, let's say the lighthouse is somewhere here. Let's say that's L. And the distance from the location of the boat to the lighthouse, it is 20. It is 20 kilometers, and it is at a bearing of 230 degrees, right? So bearing of 230 degrees starts from, I'm always starting from here and then go all the way there, right? So from this point all the way down to this point, that's 180. So we have to go additional, this colored yellow part, that will be extra 50, right? Extra 50 degrees, right? So, or I can say this part, let me maybe color that red. This red color part, that would be 40, right? Because that's a right angle, right? So this is 40 degrees. Okay, so it's gonna keep on going to the west, and then at one point it will reach, it will reach a place where the distance between the boat and the lighthouse is 16. So about there. So that's it, that's 16. Just kind of a little bit shorter than this 20 that we have there, right? So we have this triangle now, and they want us to find the distance from the initial place to the new position. Okay, so so that's it. That's the first. That's actually part B that we have to find here. Right, this is part B. Okay. Now, before I solve that, let's look at part C. Alright, so part C, they're asking us how far does the ship sail beyond this point before the lighthouse is again at a distance of 16. So let's say if the ship keep on going, there will be another location, another position where this distance is also 16. Right, this distance is also 16. So starting from 20, and then keep on going, and it is kind of getting closer and closer to the lighthouse, and then at that point, it hits a point where the distance is 16, and then keep on going. It might get closer and closer, or further and further, but there's another location where the boat is also 16 kilometers away from the lighthouse, right? And that's what part C is asking us. Part C wants us to find this new location here, right? So how much more do we move? Right, how much is that? I'm gonna say, let's say the first one was x1, and I'll call this x2. Right, so that's what they want us to find. Okay, so the question is a little bit complex, and so which involves ambiguous triangle, right? So let me kind of just resketch this, and when I come back to the video, you guys can see better sketches. Okay. Alright, so here I have made I hope this is a better sketch of this triangle, starting from here, goes there, come down, and then go back up. Right? This is the first location where the distance between the boat and the lighthouse is 16 kilometers. Okay, so here it is. And here, this is x1. This x1 is what we have to find. However, we do not know what the angle here is, so we cannot apply sine rule yet, right? But we do know this 20, so maybe I can figure out this angle, right? If I can figure out that angle, then I can just use 180 minus this 40 minus this red angle, and I can figure out what this angle is. Right? So let's say if I call this angle, let's call that A. Okay, call this A. Okay. So let's apply sine rule then. So I will have sine of 40 degrees, sine 40 over 16 is equal to sine of A, right? Sine of A over 20. Right. So my sine of A is equal to 20 times sine 40 divided by 16. Right? 20 sine 40 divided by 16. So my angle of A, if I use my calculator, I should get approximately 53. Let me put that right. Approximately. We should put that approximately sign, okay? Because we're talking about IB math. They do care about math notations. And I'm going to round it up. Since this is my intermediate working, I'm not going to round it up to just one decimal place just to be safe. I'm going to round it up to 3 decimal places. Okay, this is 3 decimal places, 3 dp. Alright, so my A is approximately 53.464 degrees. Now, but that's not the only angle that I get here, right? Remember, one of the rules was sine of theta is equal to sine of 180 minus theta, right? 180 minus theta. That's one of the rules that we talked about, right? So another possible value for A would be, okay, so let's say if I call the value we just found, let's say we call that A1, right? So another angle for A, let's call that A2, would be 180 minus that, which is 180, and put that in your calculator. I have about 126.536. Okay, and because we're dealing with ambiguous triangle here, we need to take care of both of them. Alright, so let's see what we have here. Alright, if you look at the sketch that we have over here, the angle A, it is an obtuse angle, right? So we found 2 values for angle A. One of them is obtuse, another one is acute, right? So it seems like this angle A over here, this is actually in fact my A2, right? So where does this A1 go then? This A1, that 53.464, where does it go? Okay, so let me change that to blue. This A1 is actually the angle that we have over here. Does that make sense? Alright, so what I'm going to do now is I'm going to pause the video and I'm going to create another sketch. Right? Okay, so here is the new sketch, and this sketch is based on this. Starting from here, goes all the way down to the location where the boat is 16 kilometers away from the lighthouse for the second time, right? And then go back to that 20. Okay, so we're talking about starting from this triangle here. Okay, so it's right here. So starting from here, go all the way down there, and this is the second time where the boat is 16 kilometers away from the lighthouse. So like the lighthouse over here, and this is the 20. The 20 stays there. This 40 degrees stays there. The only difference is the distance, right? Now, kind of the base of the triangle is a little bit longer. And I have this blue angle. This blue angle is what we found just now. That's my A1. And all we have to do now is find the distance x2, right? Okay, so now if I apply sine rule, right? In fact, even before I do that, I know this is 40 degrees. I know this is 53.464. I can find this angle, correct? This angle L, right? Let's call that angle L, right? So that would be 180 minus the other 2 angles. So let me just put that in your calculator. And that is 536 degrees. Okay, and then we can now apply sine rule. However, when I apply sine rule, what I'm finding, I will be finding this length, right? Not x2. The question here for part C, it is asking how far must the ship sail beyond this point. That point meaning this, at this point. So they're only interested in x2. But if I apply sine rule over here, I'll get this entire x2 plus x1, right? But that's so they're only interested in x2, and we need to give them that simply by subtracting this whole distance. Let's call that y, right? Y subtract x1, I'll get x2, right? Okay, so let's just find y first. So sine of 86.536 over y, right, is equal to sine of 40 over 16. Okay, so at this point, you might be asking, is it okay if I use this blue angle and this 20 over here? Yes, you may. However, the reason why I'm using 40 degrees, this 40 degrees and the 16 is because of accuracy. This was not rounded up, right? That was given by the question. So I'm trying to make my answer as accurate as possible. Okay. So I think it's a good habit to use the data that's going to give you the higher accuracy. Okay, so now let's start for y. So my y is equal to, you put that in your calculator, your y will be equal to, it's going to be approximately, again, I'm rounding this up, right? So this is still intermediate working, so I'm going to round it up to 3 dp, 24.846. Okay, so that's the total distance y. So now all we have to do is subtract y with x1, and I'll get x2. Right? So x2 is equal to y minus x1, which we still haven't found x1 yet. Right? So we will have to come back to we will have to find x1. Right? We will have to find x1, and then just put that in there, and I'm done. Right? So let me put on the y value first. This is 24.846. And then let's find what's my x1. So we have just mentioned that this obtuse angle, right, this is an obtuse angle, so which means the angle for that is going to be 126.536, right? Which means I can kind of resketch instead. In my case, I will have to resketch. For you guys, you don't have to. You can just add it to it, right? So let me resketch this. All right. So here it is, right? So here it is. So I have the exact same triangle, right? But now I have filled in this angle A, and it is 126.536, right there, the red one. The 40 degrees is still there, the 16 is still there, the lighthouse is here, okay? And the original distance is 20. So now if I know this is 40, this is 126.536, I can find this angle, right? This blue angle right here. Right? And that is gonna be the calculator, 180 minus the other two angles, that angle will 13.464, 16.464. And then after that, we're just going, and what we have to find now is my x1, the distance over there. So just apply sine rule again to make sure you use the information that's going to help us with accuracy. So I'm going to use the 40 and the 16 right, is equal to sine of x1, sorry, sine of the 13.464 divided by x1, right? And use your calculator. Your x1 is equal to approximately 5.796. Okay, so x1 is approximately 5.796, and I can just put it back in here, right? And do that. So I will have 24.846 minus 5.796, and the answer is 19.05, and that's it. Good luck. We'll talk about D in the class. See ya.